Okay, so if I have me a bunch well, an idea, right? So my idea is I have one point and I have a line. Okay, say I have a point on the y-axis, so it has coordinates of 0 and some value. I'm just going to call that a. Yeah, so some value a that's on the y-axis, right? And a line which has which is given by the formula y equals minus a. Yeah. So so I have in this case a is equal to 1 and minus 1, so it would be so then what is a set of points that follow that let's see, the distance between B and C is equal to the distance of C and A. C and A, you clearly see, is a perpendicular distance, right? So the perpendicular distance between C and A, yeah, is equal to B and C, right? And what shape do I get if I move this around, right? You may see that it's a little bit of a curve, but we want to figure out what's going on, yeah? So if I get me like a few formulas, and then we can use what we know about our prior math to help us out with this. That's how learning works, right? We start from what we don't know and we get to what we know. Yeah. So here I would have my distance formula, right? My normal distance formula between 2 points, right? I'm going to call this point C with coordinates x. So my point C has coordinates x, y, right? Some x and some y value, right? My point B has coordinates of 0 and a, right? And my bottom line here, right? Y is equal to minus a. Yeah, all cool? So it has some a value, and that's on the y-axis, and this is like a line, right, underneath. Yeah. So what we can apply is first off our distance formula, right? So the distance between these 2 points, the square root of x minus 0 squared, which is just x squared, plus y minus a all squared. Yeah. And so this distance is the distance between B and C here. Yeah. Now the distance between C and A, we can start applying our perpendicular distance formula. That's the perpendicular distance formula. First off, you got to get this into its general form, which is just y plus a is equal to 0. General form where everything equals 0. All cool? Yeah. Yeah. So then from here, the perpendicular distance formula is the absolute value of ax1 plus by1 plus c all over square root of a squared plus b squared. Now in this case, the a and b aren't the same thing as these guys here. These are two different values, yeah? In this case, it's just the formula. A, b, and c. A is just the coefficient of x. B is just the coefficient of y in the general formula. And c is just the constant term, yeah? So it doesn't represent anything here in this case, right? So when I'm plugging it in this formula, is equal to the absolute value. Now the coefficient of x here is 0, right? So it's just 0x. I'll write this as 0x plus by. Now b is 1, right? 1y plus a, right? All over the square root of a squared plus b squared. Now my a here is this guy, 0, which is just 0 squared. 0 squared plus 1 squared. Plus 1 squared, right? Okay. 0 squared plus 1 squared is 1 squared, right? And the square root of 1 squared is just 1, right? So I can write this as the absolute value of y plus a all over 1, which is just the absolute value of y plus a, yeah? I don't want to mislead anyone. Yeah, so what I was saying is I just don't want to mislead you here. This is just a formula list, yeah? Okay, oh cool. Yeah, what I'm doing now. Okay, so then yeah is equal to y plus a. Okay. Now when I have these two sides, right? By first instinct, probably you should be able to do is square both sides. Yeah. So then I have x squared plus y minus a squared is equal to y plus a all squared, right? Expanding out, we get x squared plus y squared minus 2ay plus a squared is equal to y squared plus 2ay plus a squared. Yeah, y squares cancel, a squares cancel. Now let's bring this 2ay over to the other side, right? And that's basically adding 2ay on both sides. X squared is equal to 4ay. Oh, let's bring the 4a on the other side just to make it a little bit clear. X squared all over 4a is equal to y. Clearly, this is what a parabola looks like, r quadratic. And if we move our points around, you do notice that the set of points that follow this traces out a parabola. Yeah, this is our first step on like how locus works. And when we build on this idea of locus setting rules for the distances between a line and a point, and by tweaking a few things, we can what we can do is we can get some very interesting results. Thanks.